Hello, my name is Roberto Carlos Montañez Ferra, and this is my final presentation of the key activity. First, we have the introduction, and in the introduction we can find the justification, where I declare that the inclined plane wasn't considered a simple machine until the Renaissance, when Galileo Galilei included the inclined plane in his work on mechanics, but it wasn't his invention. Galileo said that in vacuum, all objects fall at the same speed regardless of their mass. The importance of this experiment is to check if the ideas of Galileo regarding free falls affects a body in an inclined plane. The question that I'm trying to answer is, if a body with greater mass will slide down an inclined plane faster than one with smaller mass. This is the objective of the experiment, and for this experiment I will be using the software Tracker to help us measure time. The variables that I am going to use are mass as our independent variable, because I will be changing the quantity of water in our water container, so it will be easy to weight our object. This variable will have a value from half a kilo to 3.5 kilograms. Time will be our dependent variable, because this one is the one that we want to know if it changes depending of the value of the mass. And finally, our control variables. These ones will not change during the experiments. These ones are the angle of the inclined plane, that will always be at an angle of 40 degrees over the horizontal. The distance that our water container will be sliding is of 1 meter. And finally, the gravity, that in our planet is of 9.8 meters over second squares. The materials that I used during this experiment were a water container as our object that will be sliding down the inclined plane, water to fill the water container and change its mass, a wooden plank as our inclined plane, a camera to record the movement and with that video use the software Tracker to track the movement of our object with different mass. And my hypothesis is that the object with greater mass will slide down faster down this inclined plane, and this hypothesis is against what Galileo said, so it might be super wrong. The steps that I followed were: first, I placed the camera and started a recording. Then I placed a wooden plank in front of the camera at an angle of 40 degrees. Then I filled the water container with the desired quantity of water. Then I placed the container at the highest point of the wooden plank and let it fall. I repeated this experiment with different quantities of water, and with the video I took, I used the software Tracker to determine the time the object takes to slide down the inclined plane. And now I will show you my results. This is the graph of 1 liter of water, 2 liters of water, and 3 liters of water, which are the equivalent of 1 kilogram, 2 kilograms, and 3 kilograms. And as you can see, they are pretty much the same, and the slight difference in time, it might be human error. And my hypothesis was incorrect. The value of the mass doesn't affect the time it takes for an object to slide down an inclined plane. After a further investigation, I found an article written by Anne-Marie Pendril that says that friction, gravity, and inertia are proportional to the mass, so the mass doesn't affect how fast an object slides down an inclined plane. Galileo was correct about if in vacuum two bodies with different mass fall, they will hit the ground at the same time, and this can also be seen in an inclined plane because everything is proportional to the mass of the object falling. Here are my references, and thank you.